Hey chemistry crew, Mr. Collier here. I want to show you how to do pages 12 and 13 in your gases packet. Here we are taking some temperatures and some volumes and graphing them. The first thing you need to do is take your temperatures and convert them to Kelvin, because all of our temperatures need to be in Kelvin in this gases unit. So that's just going to be adding 273 to the Celsius temperature. So you're going to get things like 373, 283, 274, etc. Right? You're just adding 273 to those numbers. Hey, look, this one's 273. From there, you're going to do a few different things. One thing you can do is look at the relationship of V over T. So you can take that volume and divide it by the Kelvin temperature, and you'll find that this is a constant ratio. That's not going to be a surprise, because the next thing you're going to do is graph it. And when you graph it and you have volume and temperature, and here's a graph I made earlier, you've got your volume and your temperature, and that relationship is linear, it's constant. So when you make this graph, you get this straight line. And that straight line allows us to draw the conclusion: as temperature increases, volume increases. In other words, as you heat a gas, its volume is going to expand. The slope of this line is going to be constant. Single slope tells you it's a linear relationship. Back to page 12 for a second here. So we can see that this is a direct relationship. And we can see that as it crosses the y-axis, that's 0, 0, which would be absolute zero. Those are the questions that you had to answer there. And one last time on the graph, again, Charles' law shows us that there's a direct relationship between temperature and volume. Let me know if you have any questions.